So I came across the Biquad Yagi design over a year ago now on the internet, and all I had was a picture and a couple of measurements in German or Polish, I believe, I can't remember now. And I was quite intrigued by it because, as most of you know, my favourite antenna of all is the Biquad antenna, hands down over all the other designs. And I came up with this design, changed the measurements slightly, for a Biquad Yagi hybrid antenna. Now this has been quite a good antenna. It really is a powerful little antenna for its form factor size, and I have used it quite a lot over the past year, but unfortunately the design is actually flawed, that you have to keep performing maintenance on this and resoldering the elements on, because they are quite weak and they do snap off. And as you can see here, because of the metal I used to construct this is steel, it's starting to rust as well. The humidity has got to it and started to rust away at those elements. So probably for the past 6 months, but really the last 4 or 5 weeks, I've put quite a lot of time and effort into redesigning the Biquad Yagi, using materials and a method that I could actually use to mass produce it and actually sell it, hopefully, and you know, have a design that is more substantial, and obviously, you know, a design where you don't have to keep soldering on the elements because they actually fall off. So I started off by using cardboard, and I did decide early on that the main material I was going to make the finished antenna out of was PCBs, and actually etch the elements directly onto the PCB. That way I can use design software like Eagle or something like that similar, where I could actually produce some Gerber files and actually send it off to be manufactured. But at this stage I just wanted to get a basic idea of the actual design, so I used cardboard, which is something you ought to, you know, if you come up with an idea, actually design it out of something that's cheap and easy to work with, and cardboard or thick card is the ideal medium. Now this one in my hand here is a 5.8 gigahertz one, and another reason why I looked at PCB material is because people have asked me over the last year or so if I would design one of these for the 5.8 gigahertz frequencies, but unfortunately the tolerances involved, i.e. you have to get down to 0.5 of a millimeter. It will be virtually impossible to make that out of wire, you know, to get it with any degree of accuracy. So, you know, if you use PCBs, you can actually get that 0.5 millimeter tolerance, no problem. So after I decided that I was going to use PCB material to actually produce the elements, I then looked at how I was going to hold them all in place along the axis here, and each one has to be held a specific distance away from the last one, and I looked at using this kind of method where you know, it latches in with the PCBs themselves and holds them all in place, but to actually produce that here in my workshop I've got no specialist tools for doing anything like that, and it'd be really difficult to get it accurate each time. And also I'm going to need a lot more than 2 of these because it wobbles too much in its axis to be an effective antenna. So I did look at this design here, and using 4 2 on each side, but again it does move slightly, but it just looked too boxy. It didn't look you know, like a nice design. I wanted something a lot more like this, where the actual PCB material has these triangles on the end. It just you know, it looks a lot better than the box or you know, rectangle shape here. So I then looked at using rods to hold this in place, and this is a lot more stable. And here's the 5.8 gigahertz one of its 2 rods, and I think you know, it looks a lot better than the boxiness of this one, but it's still going to need more than 2 rods to hold these elements in place. So I then looked at using 4 rods. So I moved on to this design, slightly thinner rods, but because there's 4 of them, and this really does hold it in place now, it doesn't move at all. So that's what I decided to go with. And bear in mind, I hadn't actually produced a working prototype at this point. It was just making it out of cardboard to get the dimensions right and the actual design itself spot on, where you know, you got that rigidity, and I was happy that I could actually make it in quantities. So the next design that I made again out of card, but this time I used sticky back copper tape, and you've seen me use that in previous videos, and I stuck it down over the top of the elements and then flooded with solder on there just to tin it to make sure that each point was actually connected like a piece of wire would be. And this is actually a fully working prototype, even though it's made out of card. And I was really happy with the performance of this, and it performs just as well as the finished item, but obviously because it's card, you know, it's not going to last forever. But I knew then that this design, especially for the 2.4 gigahertz, was the one to go with. So then I moved on to looking at the 5.8 gigahertz biquad, which is probably the main reason why I went back and looked at this. We had so many people asking if I could produce one of these, and I decided to go with this kind of a design where all the elements are actually tapered in, so they actually slope together, and using the 2 dowels here to hold them in place. But again, you know, I wasn't quite happy with this, and although I do like this design of the tapered ends, you can see here it's quite difficult for me to reproduce this here in the workshop with just using a Dremel, for instance. So I decided to actually change the design for the 5.8 gigahertz and go back to a square shape, because it's much easier to actually produce, especially with it being so small. So for the 5.8 gigahertz, I did decide to go back to the square design, but I used 4 dowels to hold them in place, all the elements, and spaced out there, 2 on each side, so it's nice and strong. It doesn't move around, but it was just a lot easier for me to actually produce a working prototype here in the workshop rather than the tapered edges. I couldn't get it you know, accurate enough with my Dremel tool alone. So the next part of the video is step by step how I you know, constructed this 5.8 gigahertz Biquad Yagi. Because I had to go back and redesign the elements, I decided to film it this time, and the methods that I used to construct this are the exact same methods of producing the 2.4 gigahertz one, but by no means it's not you know, a step-by-step on how to etch circuit board. I do show you some of the methods that I use, but if you have never etched circuit board before and you want to attempt to make one of these antennas, then I suggest you do a lot more reading first, and then come back, download the PDF files that I've included in the description, and you can have a go at making your own. And you know, initial test, these are really powerful antennas. So now what you're going to have to do is download the template, the PDF template, and there's a link below for both templates, the 2.4 and the 5.8 gigahertz templates, in the description below. And you're going to need to print those out using a laser printer. And what I've used here is some PCB transfer paper. Now this can be quite expensive, especially if you're not going to do a lot of PCBs at home yourself, but you can also get away with using some overhead projector laser film and print it out onto there and use this in exactly the same way. That also works really well. And of course you're going to need some photoresist PCB board. It has a special layer underneath this plastic film here that protects it from the light, and it actually reacts with the light. And what we can do is use this film over the top on the light box, and we can imprint that image straight onto this PCB. Now to etch this, I'm actually just going to use a tray with some of the solution in. I'm not going to use a heated bubble etch tank. So what I actually do is break it up into smaller pieces, break the template up into smaller pieces with smaller pieces of circuit board. Don't try and etch it all in one go, just do it in small chunks, and you'll get better results that way. So to develop it then, what you need to do is peel off the protective layer on the board itself to expose the photoresist surface, and then place the image over the top. Now my particular box, it takes about 2.5 minutes of exposure time. Some of the more modern light boxes and the little LEDs I've seen people make these up with, you can cut that time down. So for my box it's about 2.5 minutes. Now next we're going to have to make up some developer solution, and this is PCB photoresist developer, and it comes as grains. You can also buy it as a liquid, and you dilute that to the correct amount of water that the manufacturer advises on the back here, and it does differ from manufacturer to manufacturer, so make sure you read their instructions and dilute it exactly how they say. And you just gently rock the liquid back and forth over that circuit board until you start seeing the ink come away from the board. So now I've got my plastic tub here, and I've got about half a litre of ferric chloride in there, and I've got it at full strength ferric chloride. I haven't diluted this with water or anything, purely because we're not using an etch tank with a heater, and it does actually work a lot quicker using it this method. It probably etches away in about 10 minutes here in the workshop doing this method. Now I have got some protective gloves on here, and the ferric chloride can be quite dangerous to handle, but it's by no means an acid. If you get this on your hands, it will not eat through your hands and your skin and everything else. Like there's a few videos out there that say that, or burn a hole through the table. It's actually corrosive liquid, so it works quite slowly. If you do get it on your hands, don't panic, just go and wash it off with some warm soapy water and you will be fine, but it does stain quite badly, so you know, if you get it on your clothes, you're never going to get it out. So because I'm using it in my workshop, I have got the heater on in the workshop, but to speed things along a little bit, the method I like to use is I've got a second tray underneath here, and I've got a kettle, and it's filled with hot water, not boiling water, and I just pour a bit here in this trough, and it just helps to heat up the ferric chloride and make it work that little bit faster. And again, like I said, it's not dangerous stuff, this ferric chloride. I've got more chance of actually causing more injuries to my hand using the hot water out of this kettle than the ferric chloride itself. And top up some hot water in this bottom tray, and it should transfer its heat nicely to warm up that ferric chloride. I actually got this method by watching somebody melt some chocolate one day. And then you want to keep rocking it backwards and forwards so that ferric chloride can etch all the copper off that board that we don't actually want. So I've now got the elements etched out, and I need to cut these out of the circuit board, and the only way that I can do it is to use my Dremel tool with a circular wheel. It's a little bit messy and it takes a little bit of time. It's quite time consuming. If you have a bandsaw or something like that, you could probably do it a lot quicker than me. So now that I've got them all cut out and I've drilled all the holes, what I'm going to do now is I'm just going to go around and remove any little flakes of copper that might be still there that never got dissolved with the etching process, and I'm going to give it a wipe with some isopropyl alcohol just to clean them up, and then I'm going to spray the reverse side of all these black, and the front side I'm going to put some clear lacquer on. So I'm going to start putting the antenna together now, and I've got a very short pigtail here with an SMA connector on that I'm going to use to actually connect to the antenna. I've got 4 50mm lengths of dowel in here, which is 3mm in diameter. That fits just nicely into the 3mm holes. Here I've got some M3 machine screws and some hex spacers and bolts, so I've got everything we need to put it together, so we'll start constructing it. So first of all, what I'm going to do is get a little bit of epoxy on each of the 4 dowels here, and I'm going to glue those in place first onto the copper reflector. And to make sure that the epoxy sets with the dowel in place there, nice and vertical, just use one of the elements there to support it as a jig, so to speak, until it sets, and then you can just remove that one. And while the support beams are drying there with the epoxy, I'm just going to use a little bit of epoxy around the SMA connector there just to set it in place on that back plate. So I've bolted on the back plate using the M3 screws and those hex spacers, and I'm now going to place the driven element part of this antenna down onto the support beams there and solder it directly to the coax that I've prepared ready to go through those 2 solder points on that driven element. So the driven element is in place and it's soldered onto the coax there, and the space between the driven element and that back reflector is exactly 8.5 millimeters. So what I'm going to do now, I'm going to put the rest of the parasitic elements in place, and they all need to be exactly 7.5 millimeters, all spaced out along the supporting pole here. Okay, so I think it's time for a small test here, and what I've got is the alpha card, and I'm going to start off by scanning with one of these longer range dipole antennas. Unfortunately I can't do the 5.8 GHz one, but I am going to be producing a 5 GHz one in the future, and I'll be testing that. But I'm going to test the 2.4 GHz Biquad antenna against this longer range dipole antenna, and I thought it'd be also good to connect up the original Biquad Yagi antenna that I built and test this PCB one against this wire one and see if it makes a lot of difference now that the wavelengths are exact on the PCB one, whereas this one you do have errors because you know, you're making it by hand. So as I said, we're starting off with the rubber duck antenna on the alpha card. Now I've got the test router about 120 meters away going through 4 brick walls, so I needed it a little bit further away because even the original Yagi Biquad is quite powerful, and I don't want it to max out at 100%. So the rubber duck antenna is not doing too bad for the range and the walls that it's got to cut through. It's just above 50% there, so what I'm going to do now is swap that out for the original Biquad Yagi, and then we'll test it against the new one. So jumped up straight away there, it's into the 80%. So I'm just trying to dial it in because it is directional. And it seems we've levelled out there at about 87% I think, jumping up slightly. So not a bad antenna at all when I first built this, and that's why I have used it quite a lot since. It's not a bad performing antenna. So what I'll do now is disconnect that and put it into the new one that I've built and see if the tolerances actually etching the circuit board improve the signal. So I'll just try and dial that in. So improvement over the original one, that's up into the about 95% there, almost touching 100%, so big improvement there over cutting the wires manually like I did with the first one. And it seems quite stable at around 96-97%, so definitely impressed with that. So hopefully you found that video interesting, just how you get from a cardboard design like this to a finished prototype like this one. And yes, I am going to be taking the 2.4 GHz into production. As soon as I've got the Gerber files finished, I'm going to put an order in for around you know, enough PCBs to make around 10 antennas. But if that works out well, then I will do a run on the 5.8 gigahertz one as well, and I do want to produce a 5 gigahertz Wi-Fi one as well. So like I say, I hope you found this video interesting, and I am actually really taken back by how this channel has grown, especially over the last year. I'm now getting around 8,000 views a day consistently, average views a day, you know, and it's just growing and growing and growing. It doesn't seem to, the little graph on YouTube doesn't go down, it always keeps slowly crawling upwards. And I think Dave Jones on the EEV blog, I think he did a video when he was averaging about 8,000 views a day, and that's when he decided to go full time. But definitely can't go full time on this channel yet, but if it carries on growing, it really is, I find it amazing how many people out there find this stuff interesting. I didn't think there'd be that much you know, interest in doing videos about this, but obviously the hobby of quadcopters has really taken off, and that's added to it as well. And yes, I am going to have a website soon with a small online forum, hopefully, because it really is difficult to answer specific questions on the YouTube comments. It doesn't work well, and comments can get buried in all the other comments, and it's really difficult to go back and amend comments that I make and to help people. So I think a forum is going to be the way to go. And yes, there is a shop coming as well, where some of the antennas that you see me build, I will be making smaller runs on each and selling those as well if you're interested. Hopefully, you know, I'll make enough money from that to support the channel so I can get more equipment in to build many more antennas. So if you enjoyed the video, please give it a thumbs up. As always, drop a comment below, and if you've got any questions, and the actual PDFs for both these antennas will be in the description box, so you can have a go at making them yourself if you want to, and hopefully you'll join me on the next video.